students, welcome to the rapid revision of our physics chapter electricity. I'm Aditi, your very own physics teacher on the platform Deeksha Vedantu, where we teach completely in English because we understand that you have to write your exams only in English. So for your pre-boards, we have started this series, rapid revision series, where in all subjects we teach all the chapters in just each chapter in just 25 to 30 minutes so that you can revise them very quickly and very easily. Now let's start our first chapter, which is electricity. So what we read in electricity first? Of course, charge, ma'am. What is it? It's just a property of matter. We know we have two kinds of charges, positive charge as well as negative charge. Its SI unit is coulomb. And we know that like charges repel each other and unlike charges attract each other. So like charges repel each other and unlike charges, positive and negative, they attract each other. Then the next topic we come to is current. Now current is also a property of matter, but what it is the rate of flow of these charges, rate of flow of charges, and we know anytime we read rate, so we just apply T in the denominator. So current will be rate of flow of charges. Charge was denoted by Q and rate we know by T. And if I take T on the other hand side, Q will be IT. This is a very important formula. What is it? Current is rate of flow of charges. Q equals to I into T. Let's see a numerical, a very basic numerical on this topic. What it says, an electric current of 2 ampere. So I equals to 2 ampere. Flows through a wire for 5 minutes. T equals to what? 5 minutes. So we know we have to find the total charge of that passes through the wire. So Q equals to IT. We just studied. I is 2, T is 5. So Q will be 10. Now, what is the unit? We do always remember to put unit after you solve the numerical. What is the unit of our charge? That is coulomb. So, a 10 coulomb charge is flowing through our wire. Okay, next is potential difference. I have a charge. Okay, let's say I have a plus Q charge and I want to bring that charge from my left hand to my right hand. So it has to cover this distance. Let's say this distance is L. So the amount of work that I have to do to take this charge from one place to the other is called potential difference. The amount of work in bringing a charge of, now that charge is 1 coulomb for the definition of potential difference. The amount of work done in bringing a charge 1 coulomb from one point to another, from one point to another, we are bringing 1 coulomb charge. So it's called a potential difference. It is measured by voltmeter. Also, current was measured by ammeter. I have not written that here. Okay, current is measured by ammeter and potential difference is always measured by our voltmeter. Now there is one very important thing that we need to see. Also, this formula, this is what? So potential difference is the work done in bringing a charge from one position to another. But here we are using 1 coulomb. So to get 1 coulomb, we'll divide by the extra or divide by the charge. So this is the formula for our potential difference. Very good. Now a very important concept. See, we have two terminals on a battery, right? Positive and negative. The positive one is called higher potential and the negative one is called lower potential. Similarly, the conductor connected with the battery will also have a higher potential due to this battery and then a lower potential. And we always know that our current flows, our charges, let's say, we know charge always travels from negative towards the positive. This is charge, okay? Charge, not the current. But we know current travels in opposite direction. So our current is traveling from where? From high potential to low potential. Current is traveling from higher potential to lower potential, and our electron is traveling from lower potential to higher potential. Okay, very good. Moving on to the next topic, which is Ohm's law. We know this law is very, very important for our both question and our knowledge as well. And it's very easy. It says that the potential difference, we just study what potential difference is. The potential difference across two ends of a metal conductor. This is our metal conductor. The potential difference between two ends of a metal conductor is directly proportional to the current flowing through it. So, the current flowing through this conductor will be directly proportional to the potential difference across its two ends, provided, very important condition, provided that the temperature remains same in that particular time when we are measuring potential difference and current. Okay, so this is hence V is directly proportional to I. And when we remove this directly proportional sign, what comes? V equals to, we know always we apply a constant when we get rid of the directly proportional sign. So that constant here is R, which is what? Which is resistance. Ma'am, what is resistance? We'll study about that. Wait for a minute. So V is directly proportional to I, and this is our graph. What it says is, we know that V is directly proportional to I. So as V increases, I also increases. So if my V is, let's say, 1, 2, 3, this is 10, 20 and 30. So at 1 this current was 10, at 2 my current was 20, at 3 my current was 30. So it is linearly increasing. It's linearly increasing, hence our graph is a linear graph. And just remember this very carefully, the slope of VI graph, let me write it down. The slope of VI graph is what? R, which is our resistance. Okay, cool. Let's move on to the next topic. Next topic is, of course, we need to study now what is resistance. So resistance is when my charges are flowing through a conductor. When the charges are flowing through a conductor, there will be an opposing force which will try to stop the charges from moving. Not force specifically, it's just a property of our conductor in which our electrons, our current is moving. It is a property of matter itself which will try to stop the flow of charges. Hence, it will be in opposite direction to the flow of charges. So, resistance is the property of conductor that opposes the flow of charges through it. This is our conductor and this is the current passing from the conductor. So, it's a property of this conductor itself that it tries to oppose the flow of charges. I hope your property is not to oppose your numbers in your exam. So I highly recommend you to study carefully. It's your 10th boards. These are very important. Do not take much pressure on yourself. Although that it's too much, don't get into some anxiety that it's too much, boards are too much. It's not too much. You just manage your time correctly and you try to do everything calmly. Okay, do not try to oppose your numbers in your 10th boards like resistance. Okay, where was I? Oof, lots of gyan I have given you. So the current is traveling in this direction and the resistance will oppose the flow of charges through the conductor. Now, on what is the formula for resistance? Let me show you this thing first. So there are certain factors that our resistance depends on. What is it? It's length of the conductor. We had that conductor there, right? This is our conductor. So this is my length of the conductor. This is the area of cross section, not just area of cross section, and then material that we'll study later, and temperature. So my resistance depends on, it's directly proportional to the length. So as length increases, my resistance will increase, and it's inversely proportional to the area. Larger the area, smaller the resistance. So what was the last? Yeah, what it is? R is directly proportional to L by A. I can write, and we always remove the directly proportional sign and put a constant, which is resistivity. What is it? Rho. We call it rho. Just, I guess this is rho, the spelling. Okay, rho. What is rho? Rho is resistivity. Ma'am, what is resistivity? Resistivity is again the property of material, but it determines how much resistance, how strongly our conductor will oppose the flow of current. Maybe let's say I'm a conductor and there is an imaginary person that is also conductor. So if I oppose the electrons by 1 unit and the person will oppose the electron by 2 units, then whose resistivity is more? The person with 2 units. Okay, the electrons will feel more opposed by which person? Me or this imaginary person? The imaginary person, because it has higher value of resistivity. So it's a property again of a conductor that determines how strongly it opposes the flow of charges from it. For resistance, it depends on L by A, and if I just rearrange these values, I'll get the formula for resistivity. Okay, we know the SI unit of resistance is ohm, and if you want to find the SI units of resistivity, for resistance I have ohm, for area I have meter square, and for length I just have meter. So 1 meter will get cancelled and the SI unit of resistivity will be ohm meter. Understood? Now we know that good conductors are the one which lets a lot of current pass through it, which hence means that it lets the flow of charges, it does not oppose the flow of charges that much. So good conductors have low resistivity because they don't oppose the flow of charges much. But insulators, remember these words, conductors and insulators. Insulators like rubber and plastic, for good conductors it's copper and aluminium. For insulators, they have high resistivity because they oppose the flow of charges with a higher value than the conductors. Now moving to the temperature, if someone asks you, what are the factors? Is temperature a factor which affects resistance? Then yes, it is a very, very important factor, although you don't have much of this topic in your 10th class, but still it's a very important factor for resistance. So what happens for metals? For metals, resistance increases. If you increase the temperature of a metal, its resistance will increase and the current will decrease. But for insulators and semiconductors, as the temperature increases, the resistance will decrease. And hence more current will flow through them. Very good. A lot of chapter we have covered. Numerical. Ma'am, I hate numericals. See, my children, you are a lot stronger than these numericals. Okay, this is a bit gyan again, but if you tell yourself every day that these numericals have got nothing over me, okay, if I solved just 5 numericals of one formula, just one formula, pick one formula and solve 5 numericals only on that formula, you won't ever forget what the type of questions, and you'll understand, okay, these are 4 or 5 type of questions that they ask, okay, normally. And nobody can even touch me in these numericals. Tell yourself every day that I'm stronger than these numericals and I won't let these numericals mess up my boards, mess up my 10th boards, which are very important. Okay, you just need to have that mindset. And also we are bringing live classes very soon in which we'll solve chapter wise PYQs, which will also include a lots and lots of numericals. So make sure to join that live. It will be very, very important for you guys. Okay, so the numerical says that a wire of given material having length L and area of cross section A has a resistance of 4 ohm. It has a resistance of 4 ohm. And then this says find the resistance. We have to find the resistance of another wire of same material. See, this is the keyword here, my children, with the same material. So a different wire 1, let's say this is wire 1, this is wire 2, this is made up of same material but having length L by 2 and area of cross section 2A. Okay, how will we solve this question? Now the resistance is given, so first we'll just apply the formula of resistance, which is, we just study rho L by A. Resistance is given, put 4 in resistance, rho L by A. So from here the value of rho will be 4A by L. Now we know that if the material of wire is same, then its resistivity value will remain same. The resistivity of copper and another wire of copper will be same. The resistivity of an aluminium wire and another aluminium wire will also remain same. So for this another wire, this will be the resistivity, right? So for this, resistance is also rho L by A. But here L is L by 2. It's not just L, the length is L by 2 and the area is 2A instead of just A. And rho, the value of rho we already found, which is 4A divided by L, and this is our resistance. And if we solve all this, A and A will get cancelled, L and L will also get cancelled, and our resistance will come out to be 4 divided by 4. It will come out to be only 1 ohm. So our resistance, as we decreased the length and increased the surface, our area of cross section, see, length decreases, area of cross section increases, and since R is directly proportional to length, it will also decrease. It was 4 ohm before, now it is 1 ohm, hence proved. Moving on. Now these resistances, we use resistors to produce some resistances. These are connected in two kind of alignment. One is resistances in series, the other is resistance in parallel combination. What it means is, in series the resistors are connected one after the other. They are connected one after the another in a same line. But in parallel, they are not connected one after the another. They are connected from the same point and 3 different resistors are connected together and the whole circuit with the battery and all. The main thing you need to remember, the resistance in series, I remains, our current remains, what? Remains same, and at voltage it divides in each resistor. But in parallel combination, our current divides in each resistor, but our voltage remains same. So in this circuit, if this is V, then this will also experience V, this will also experience V, this is also experience V. But if I is going through the circuit, then this will get I1, this will get I2, this will get I3, and all 3 of them will have different values. In series, this will get V1, this will get V2, this will get V3, but all 3 of them will get single value of current, single value of I. Very good. Now there are some disadvantages of series combination. Why? Because see, there are 3 resistors. Okay, if one resistor breaks down, then the other 2, the current will also stop flowing in the other 2 resistors. You have seen Diwali lights. Diwali is coming, so we have seen Diwali lights, right? So if one light stops working, all the moving lights also stops working. Why? Because they are connected in series. Now, different devices in our household, my AC needs different amount of current, my iron needs different kind of current, and my mobile charger needs different amount of current, right? Different amount of current. So if they are connected in series, all of them will get the same amount of current, right? But if they are connected in parallel, they will get different amount of current, I1, I2, I3 according to their need, and hence we do not use series combination in our houses for the current to reach the appliances, so that my mobile charger does, if it just needs 5 ampere and it would get 15 ampere, of course it will get bad. Now moving on to the next topic, which is our electric power. Very important topic. Almost a lot of the times a question, even a 5 marker question has been asked from these topics. Let's see what it is. So we know, we studied all those work done and everything, right? So electric power is rate of doing work, the work we did from taking one charge to another, taking a charge from one position to another position. That was the work we done. Now the rate of that work, the rate in which we did that work is called power. So if I did that work in 1 second, my power will be 1 W, let's say. If I did it in 2 seconds, my power will be, since its rate is 1 by, so this is what? Work divided by time. This is power, right? If I did it in 2 seconds, the work will be, the power will be less. It will be half. Ma'am, how did we reach from this formula to this formula? Okay. Now we studied one formula before, which is V equals to work done by Q, correct? And the work done will be V into Q. So I can write V into Q divided by T, and Q by T, my friend, we studied, which is current, which is I, and thus we got the power as V into I. Now we know Ohm's law, which was V equals to IR. So I can also put that here. So P will be I square R, because I also have one I here. So I into IR will be I square R. If I put I equals to V by R, if I put I equals to V by R here, so V into V by R, it will be V square divided by R. Very good. Okay. Its SI unit is watt, which is 1 volt into 1 ampere is equal to 1 watt. Okay, the same, we have one more topic is electric energy. So if you multiply electric power with time, if it is the product of electric power into time, it's called electrical energy, which is, now that SI unit was watt, here if we multiply it with time, it will be watt into hour, which will be P into T. Now 1 kilowatt is a general unit of electrical energy, and we know, but we know that the unit of energy is also joule. So what is the relationship? 1 kilowatt equals to 1000 watt, we know that, and in 1 hour we have 3600 seconds. So after solving, we get this relationship, which is very important. 1 kilowatt hour equals to 3.6 into 10 raised to power, this is raised to power 6 joule. Okay, this is a very important relationship for you guys. Now we have a numerical here which says an electrical refrigerator rated 400 watt operates 8 hours per day. Now they are saying that we have a electrical refrigerator and it consumes how much power? 400 watt of power in 8 hours a day, and it runs for 8 hours a day. So the time is 8 hours correct? And the power is 400 watt. 400 watt. We need to find what? We need to find the cost of the energy to operate it for 30 days. Let's find energy first. So energy is power into time. Now power is 400 watt and time is 8 hours. Will be 30 to 100. Correct? Now they've also told that it runs for 30 days. It runs for 30 days. So we'll also multiply this by 30, which will be 9600. Okay, 9600. Now this is 9600 kilowatt hour. We know the unit of energy was kilowatt hour. So this is 9600 kilowatt hour. Did I do it right? Yeah. So this is 9600 kilowatt hour, and for 1 kilowatt hour our cost is 3. For 9600 kilowatt hour our cost will be 9600 into 3, and you can comment down the answers for this because your calculation also needs to be very fast in boards. Now one more topic is left, which is heating effect of electric current. As we know, electrons or charges, current flows from through a conductor. As these charges or this current passes through this conductor or a device, that conductor gets heated up. That conductor becomes hot and the temperature of that conductor rises, and hence it is called heating effect of electric current, because a heat is generated because of the because a current was passed from the conductor or a device. Its formula is H equals to I square RT, because it depends on current, it depends on resistance, it depends on current flowing from a conductor, the resistance of that conductor, and the time for which that current was passing. Again, Ohm's law was V equals to IR. If I put the value of I, which is V by R, in this formula, I will get V square R into T. Finish. That's it. The SI unit for heating effect of electric current, the SI unit again is joule. Now alloys, we use alloys because we will study that later where we'll use alloys. For now, alloys have high resistivity and high melting point. Why high melting point? Because we know if current passes through it and the temperature gets high, that conductor or the device might melt, right? So in certain materials where we need the application for this, we use alloys because they have high melting point. So even if a lot of current passes through it, they don't melt. Very good. So just yeah, I was talking about the applications of heating effect of current. Although it's bad that the current passes through it, gets heated up, it can cause fire and all in our houses, but the places or the devices where we take use from it, where we use it effectively, is our bulb. What is it? We have this filament of tungsten. What is it? Tungsten in our bulb. Why? Because again it has high melting point, so it does not melt when current passes through it and it gets heated up. It still does not melt, and when it gets heated up, the energy gets converted from heat into light, and hence we get light from electric bulb. The filament is made up of tungsten. This gets heated up and emits light, and the air around this filament inside that glass bulb, it is filled with our inactive gases like nitrogen and argon. Inactive means that does not react with each other or with another material in that bulb. So they are made with inactive gases like nitrogen and argon to prolong the life of filament. Okay, next one more thing is left, which is electric fuse. What is electric fuse? Let's say that this is my circuit of in my house. This is my fridge, okay, then this is my plug which I use for charging my mobile, and then another appliances. So what happens is, sometimes the current in our houses comes in between the range of 5 ampere to 15 ampere. Let's say sometime a 20 ampere current, from by mistake a 20 ampere current comes into our house, okay. If it reaches my charger and my charger is connected with my mobile, it will get burned, right? My mobile would get burned. And if it reaches my electric bulb, they can get burned, and lights, they can get burned. So it's very like difficult, it's very hazardous that if by mistake maximum more amount of current comes into our houses, the devices can get bad, they can get destroyed. So we used the heating effect of electric current in an application to make a device that says, to make a device which is electric fuse. So what it does is, we connect it with in series with our appliances. So this is my fuse. So it has low melting point. What it has? Low melting point. So as soon as a 16 ampere, let's say, current comes into my house, this will get, this only has a capacity of 15 ampere. If 16 ampere comes, this says, oh, something bad is happening. So what it does is, it melts, it breaks the circuit and stops the more amount of current from going into my appliances, and thus protecting me, my house, my wires, my appliances, okay. Protect circuit and appliances by stopping the flow of high electric current, prevents short circuiting, which we studied in magnetic effects of electricity, electric current. Then low melting point, of course, it melts and stops the flow of current. I told you that we use alloys. It was made up of aluminium, copper, lead, iron. Although alloys might have high melting point, but in this we used a kind of alloys that helps us to protect our circuits, and it placed in series with the device. So what happens when large current flows, temperature of fuse increases, it melts and breaks the circuit. And hence we are done with our electricity chapter. I hope you liked the video. I hope it serves the purpose of revising you in a quick manner. And for more updates, for more videos like this, we have also started a 5-minute 5 marks series where we teach every topic in just 5 minutes on the basis of previous year questions, which also comes in like 5 marks almost every year. So join our WhatsApp channel to get updates on those videos so that you can revise quickly, easily, without any delay for your pre-boards. And I also urge you to subscribe our channel. We are putting a lot of efforts for your boards and pre-boards, and if you need any help, just reach out to us. Subscribe our channel, hit the notification bell. Tata, bye bye.